This is elementary algebra, factoring using the AC and the grouping method. On page 427 of the textbook, we have a guideline for how to solve equations by factoring. So the first thing you have to do is make sure that the equation is in the form ax squared plus bx plus c equals 0. Then you factor the side of the equation that has that trinomial term. Using, in this case, our method will be the AC method. When you apply the zero product property, you could solve the resulting equations and then finally check your answers. Problem 91 on page 429. 16x squared minus 72x minus 40 equals 0. The first step in solving an equation with polynomials is to determine if it's in this form ax squared plus bx plus c equals 0. It looks like it is in this case. So we can go ahead and find factors of 16x squared minus 72x minus 40 such that it equals 0. To simplify, let's take a greatest common factor out. In this case, it's 8. If we factor out an 8, what's left inside will be 2x squared minus 9x minus 5. Now let's just ignore the 8 for the moment because it's a constant and it won't affect the equality. But we will find factors of 2x squared minus 9x minus 5 using the AC method. This now is in the form ax squared plus bx plus c, with a being 2, c being negative 5, and b equals negative 9. Now I said it that way because there are two factors of a times c whose sum equals b. What are those factors? Well, we might have to do some trial and error. So a times c, we'll note, is 2 times negative 5, which is negative 10. Prime factors of negative 10 are plus or minus 1, plus or minus 2, plus or minus 5 in some combination. With a bit of trial and error, we can take the first two terms and make that the first factor of the 10, and we'll be left with 5. So it'll be 2 times 5, but we note that it's got to be a negative, and the negative can go with either the 2 or the 5, such that if the product is 2 times 5, does 2 minus 5 or the 5 minus 2 equal 9? In this situation, it does not satisfy the criteria. So we'll have to look for another combination of the prime factors. We can go with the second, 2 times 5 and 1, which means that we can go with 1 times 10. Again, this negative can go with the number 1 or the number 10. And we ask 10 minus 1 or 1 minus 10 equal negative 9. It seems like this one, 1 minus 10, satisfy both criteria of being factors of negative 10 and equaling negative 9 when you sum them. So let's go back to our original problem, in which the parenthesis can be rewritten as 2x squared minus 9x minus 5, knowing that the negative 9x can be a combination of negative 10x plus 1x, based on what we found over here. And of course, this will be multiplied by 8. We can group the four terms here in such a way. For the first term will be 2x squared minus 10x, and then we'll add the next two terms in a group of 1x minus 5. And all of this then will still be multiplied by 8. Now the hard bracketed terms, we can take out greatest common factors still to simplify. So for 2x squared minus 10x, we can factor out a 2x, which is the greatest common factor, and have left inside a 1x minus 5. The second term is a prime, so we'll just keep it as such, as 1x minus 5. And all of this is multiplied by 8. Again, we can see in the hard bracket that 1x minus 5 is in both of these two terms. We can factor that out, leaving the first term with 2x. And because we took the whole entire thing on the second, the only factor left is 1. And all of this is multiplied by 8. And now we can put back our right-hand side of the equation for 0. For this to be true, we know that the first term has to equal 0, or the second term has to equal 0. Now, working with one equation at a time, if we subtract, we add 5 to both sides of the equation, we'll get 1x, and then the 5 will cancel to get x equals 5. For the second equation, we can subtract negative 1 from both sides and get 2x equals negative 1. Divide by 2 on both sides, get x equals negative 1/2. Now, as an exercise, you can check whether this solution is a valid solution in the original equation, and also this. So all you need to do is just plug it into the original equation to see if the statement is true.